Greetings and welcome to a lecture on the lovely topic of the one-way analysis of variance, also known as a one-way ANOVA. Now, I will tell you right now that a lot of what I'm going to show you, you will not be required to do. Much of the calculations here I'm not having you actually do for the test because, quite frankly, it would take you 3 days longer than forever to do all the calculations, and so we only have a limited time for you to take the test. But I am including them, and I also uploaded the PowerPoint for this so that you will be able to go and actually look at all of these calculations and therefore be able to not have to sit and scribble very quickly while I go through these or pause and write stuff down. So why would we use an ANOVA? We've got t-tests, we've got all kinds of t-tests. Why an ANOVA? Well, the reason why is that it allows us to compare more than two groups. The t-test is pretty much stuck with two groups. But indeed, in a lot of research, you have more than two groups. You may, for instance, want to compare two types of medication with a placebo, or two types of therapy, or two types of, or three types of whatever with two, whatever it is basically when you have more than two groups that you're comparing on the same variable. And it's a lot easier to do one ANOVA than three t-tests. Because, in fact, you may need to do more because you would have to compare 1 to 2 and 1 to 3 and 2 to 3. So once you get up into 4, the t-tests become exponentially more in number. So it's easier to do an ANOVA than to just rattle through a bunch of t-tests. And so what this does is it measures whether or not there's more variance between the groups than within them, because this is a big question. We know that groups have a tendency to have a lot of variance within them. If we look at things like height, for instance, one thing we might want to compare is the height of women versus men. Well, we know that generally men are taller than women, but men are not always taller than women. There are short men, there are tall women. It's just that, and there's very short women. The height of a normal female can go basically from, well, an average female, I should say, can go from, 5 foot to 6'6" or something, and males could do the same thing. There's a lot of variations within the group that is known as female and within the group that is known as male. And then when we get started in other sexes other than male and female, it gets even more exciting. So we're going to stick with that binary whether or not it's true. And so we want to see whether or not there is more difference between the groups male and female than within the groups male and female. Turns out there is, but that's basically the point, to see whether there's more difference between than within. And how we do that is we use what's called the F ratio. We had a T, now we have an F. This one is generally capitalized. What we're looking at is the difference between groups versus the difference within groups. We're going to make a ratio for that. So the larger the F, the larger that we have, the more there is between groups than within groups, the more likelihood that we'll reject the null, because the null basically says there's no difference. There's just as much variation within each group than between them, maybe more. But the thing is, if we have a between group number that is like 4 and a within group that is 1, yeah, there's going to be more variation between the within. So what we need to find this, first of all, is what's called the group mean, which is also known as the sample mean. It is the mean of each group by itself. So if you have 3 groups, the mean of group A, group B, and group C. But then we also have what's called the grand mean, where we add up all the individual scores. All the scores, we add group A to group B to group C, we add up all those scores, we divide by the total number of scores. So basically it's a mean covering all of the different groups. So the group mean is a group individual, the grand mean is all of the groups. Just don't take the group means and find the mean of them. You have to actually add everything up. Okay, so add up all the scores, divide them by the total number of scores, and that's your grand mean. The grand mean is distinguished by an X with 2 bars above it. x1 bar is the group mean, x2 bar is the grand mean. So in terms of variation, we can look at the variation basically within a group, or we can look at the variation among everybody. The group mean versus the grand mean. How different our score is from the group mean, that's within groups. So we look at how different all the scores in A are from the mean of A, and all the scores in B are from the mean of B, and so forth. But the difference between the score and the grand mean is between groups variation. And those are basically the ratio. We're doing between groups divided by within groups and see what we get. So for instance, if we wanted to look at the percentage of COVID, we could look at the percentage of COVID, for instance, in the entire country, that would be the grand mean, or compare it with the states, that would be a group mean. Where is there more variation? Across the country or in states? If some states have it much worse than others, then, you know, it's different ways of looking at this. Or counties versus states. So we're looking at variations to see whether the counties have, you know, basically less variability than the whole state does. So how do we do this by hand? This is where I'm just going to whip through it, because like I said, I'm going to whip through some of it, because you're not going to have to actually do the calculations, but you are going to have to understand where they come from. The first thing we need is a sum of squares. This should be familiar to you. We need a within group sum of squares, or SS sub W, where we subtract the group mean from each case within a group, x minus x bar. We square that difference, and then we add them up. It's easier to do this if you are doing it by hand to get a chart. Make a chart. The first column are the scores, the second column is the scores minus the mean, and the third column is that score minus the mean itself squared. Where it starts getting more complicated is the between group sum of squares. This is where you're going to start being happy that I'm not making you do this, because you have to take into account here the number of cases per group, because it's like weighing the groups. Your grades in this course are weighed. Some are worth more than others. And if you have different groups that have different number of subjects in them, you have to weigh them when you're coming up with this between group sum of squares. So you subtract the grand mean from each group mean. So if you have 3 groups, you only have to do this 3 times, 1 for each group, okay? Square the difference. Again, we're doing sum of squares. And then multiply each group's square deviation by the number of cases in each group. So it's easier because there's a whole lot fewer things to subtract, but then you have to remember to multiply, because this weighs that grade. It weighs that standard deviation by how many individuals are in that group. Add them up. So let's turn these into estimates of variance. It's ANOVA. It's an analysis of variance. So the same thing that we did with the t-test when we were looking at the same estimates of variance, you divide the sum of squares by the degree of freedom. Except, of course, the degree of freedom here is a little different. The degree of freedom for between groups is called df sub b, b for between. The degree of freedom over within is df sub w for within, so we have between and within. Again, we try to name them what they are. How to find these? This you may want to know. Each group is considered a category. Category is called K. So instead of A, B, and C, well, we have K, K, and K. Ooh, that's a bad. Maybe we need more than 3 groups. Okay, A, B, and C. So to find the degree of freedoms for between, you take the number of categories, the number of groups, and subtract 1. So if we have 3 groups, the degree of freedom for between would be 2, because it's 3 minus 1. For within, this is where we get into number of people and not number of groups. In much the same way that's how we found the sum of squares. So what do we do here? We take the total number of people in the entire study, and you subtract the number of groups from it. So if we have 15 total in our study, you would take 15 minus 3, and the degree of freedom within would be 12. It's good to know those formulas. It's good to have that cheat sheet. I'm going to allow you to bring in a sheet where you're able to write down formulas. You can't write down how to use the formulas, but you can write down formulas, okay? And I expect you to take a picture of that and upload it with your work. Show your work. If you don't show your work and you get the right answer, I may take points off because I don't know if you got that answer yourself or if you asked the internet for it. Particularly if you are not taking it with the Respondus browser. Okay? Show your work. Take a picture of it, upload it in the Dropbox provided. So once we get to the estimates of variance, we have the estimates of between group variance, which is MS sub B, which is the sum of squares between divided by the degree of freedom between. We have the estimate of within group variance, the mean square within, which is the sum of squares within divided by the degree of freedom within. So here it's starting to sort of fall into a category. The F ratio is the mean square between divided by the mean square within. That's how you find the F ratio. You find all those other things, and then you find the F ratio. So what I'm going to do is I'm going to give you a problem here, and I'm actually going to zip through it and show you how to get those numbers. Because on the test, as well as in the homework, many of these numbers are going to be given to you. Okay? So you're not going to need to go through all that calculation that I'm going to show you here. Here we go. We got medications. They want to see how fast the medication works. We have different times. We also have different numbers for each. That's why you have to weigh them. That's why when we're doing that, between groups, you have to weigh them. We have the number in each. We have the mean. We also happen to have the standard deviation, or actually, that's not the standard deviation, that's the variance. So here we go. The null and alternative hypotheses are as follows. The null hypothesis says there's no difference between the group. They all work equally well. The alternative says that no, at least one is different. Because there are 3 samples, the degree of freedom for between is 2, and the degree of freedom for within, since there are 13 scores total, is 10. Therefore, the critical value, for which you would look it up on that lovely chart with a 0.01, because that's what the instruction said, is 7.56. And so here we go through all of the calculations. If you really want this, you can print it out. Let's go here with the mean square. Mean square between is sum of square between over degree of freedom between. Turns out the sum of square between is 21.9232. When you divide it by the degree of freedom within, you get 10.9616. Sum of square within divided by the degree of freedom within to give us mean squares within is 75 divided by 10 is 7.5. Once we have these, we do some dividing. Plug the numbers in, divide, and our F ratio is 1.4615. Since the critical value of F is 7.56, we fail to reject the null. There is actually no significant difference between those groups. How about if you say, well, 0.01 is kind of tricky. Let's do 0.05. That ain't going to help you either. There's really no significant difference between these different medications. This is something that you should probably get used to seeing for this class, because this is generally how results are reported. And this is actually also used in your homework, and it's used on the test. So, you do a little chart here where first you put between and within for your variation or variance. You do have the sum of squares there, the degrees of freedom. Therefore, you could find the mean squares by dividing the sum of squares by degrees of freedom, and then between divided by within gives you the F ratio. Now, what you're also going to want to do if you're calculating these is you're probably going to want to have the total sum of squares and the total degrees of freedom, and to know what n is, little n, the total number, that sort of thing. But this is basically what you can use to report results, and it's also what you're going to use to do the homework. So please be very aware of this. Remember, I have uploaded this PowerPoint,
so you can look at it, so you don't have to write all that stuff down. And also please remember to show your work and upload your work when you turn in your test.